Evolutionary Robotics Insect Resource Competition by Clint Walker for the class of COSC 4560, 5560. Introduction. This project is highly inspired by the work of Carl Sims. His work in competing robots inspired me to create my own version of competing insects. Imagine two ants competing for a crumb. I wanted my simulation to be as close to what can and does occur in nature. For this project, I used a population size of 50 iterated over 25 generations. I used an elitism tournament selection with a tournament size of 2, and each robot is evaluated over 2,000 time steps. Each robot has a fitness evaluated with the function of 1 over the distance between the center of mass of the robot, the insect, and the center mass of the box, the object is trying to get to. To start things off, I started with one insect. To the left, you can see an evolved neural network of that insect. There are 12 inputs and 12 outputs. 6 of the inputs are touch sensors to the robot. The next 3 are the coordinates of that robot. And the last 3 are the coordinates to the box. The 12 outputs are the joints to the robot. The extra connections and neurons are what is resulted after the neural network is evolved. To the right, you can see a graph of the best fitness over the generations. Here's a quick snapshot of only one robot in the simulation. And here's a simulation of just one robot. Later, I incorporated 2 different insects. To the left is the evolved neural network of individual 1, and to the right is the evolved neural network of individual 2. As you can see, there are different connections and neurons between these two. This is because they are evolved separately from each other. Therefore, they have different behaviors. These 2 graphs show the growing fitness of the separately evolved individuals discussed previously. Here's another snapshot at the beginning of this simulation, but as you can see, there are now 2 robots that will compete for the resource. Next, we will see a few simulations of completely evolved robots with interesting behaviors as they compete for the resource. As stated before, my main inspiration for this project is Carl Sims' competing robots. I really like the way he was able to create seemingly realistic creatures competing for a goal. I wanted to incorporate those ideas into my own unique project. Today, research in this area has hit a ceiling. My hope is to inspire people to create and look further into simulating natural occurrences and behaviors. If I had more time for this project, I would add the opposing insect's coordinates to the neural network, and then possibly add a multi-insect or multi-swarm competition. Even though my results may not match exactly with what a real insect will do in nature, the behaviors seen are still very interesting and educational. Not every simulation goes as planned, so just for you, I added this clip. Thanks for watching.